Approaching a highway is often compared to entering a battlefield. We move at very high speeds, carried over an asphalt surface, while in both directions, often only a few meters apart, are numerous fast-moving cars of all types and sizes. Car and tire manufacturers provide us with all of the innovative means to brake safely, even in the most difficult of situations. Vehicle control is dependent on our tire's grip of the road. Only one parameter is not dependent upon technology or us as drivers. This is the condition of our roads. The braking distance of a car traveling at 80 kilometers per hour on a road with a low friction coefficient will be significantly longer than the distance expected on a road with a normal friction coefficient. Even when driving at the legal speed limit and maintaining a safe distance between vehicles, the accident on this road may be unavoidable at the exact moment that there is a need to make an emergency stop or prevent skidding on a sharp turn. From the moment a new road is paved, an inevitable process of wear and tear begins to occur. The many car tires traveling over the road leave a trail of rubber particles polishing the asphalt surface's upper layer. This process is even more rapid on densely trafficked roads, near junctions, and on roads with high slopes or tight curves. In industrial and agricultural areas, large amounts of various materials are spilled from trucks transporting various raw materials, such as food, chemicals, and agricultural products. Garbage trucks traveling from cities and industrial areas, as well as leaking motor oil, contribute their share to the road surface's contamination. Hot summer sun, repetitive wheel loads, and bitumen bleeding cause a degradation of the road texture, gradually turning the asphalt into a smoother and much more slippery surface, creating an extremely low friction coefficient. The friction coefficient is one of the most crucial factors in accident prevention and, unfortunately, one of the most prevalent causes. In order to determine a road's condition accurately and to assess skid risk, a professional assessment must be conducted. This testing process can be accomplished by several internationally accepted methods, such as the British pendulum for friction coefficient measurements, sand patch measurements for texture depth, and other rapid and continuous skid resistance measurements like ROAR. Proper use and interpretation of these testing procedures can reveal potentially dangerous road sections requiring treatment to minimize skidding hazards. In the past, only one expensive and complicated method was known for coping with this problem: paving anew over the layer that has lost its skid resistance. Today, there are more effective and less expensive solutions. Nethibi HaMifratz is proud to present two innovative methods for road surface retexturing, removing pollutants, improving roughness, and increasing the friction coefficient to prevent skidding. The mechanized roughening treatment is intended for worn-down roads with a low friction coefficient. The machine attached to a tractor hammers away the road's top asphalt layer, revealing new aggregate surfaces and creating a deeper road texture for a substantial improvement of the surface skid resistance and road safety. The process is accomplished by the use of a series of rotating drums containing tungsten steel alloy toothed discs. Each drum is connected independently to the chassis in order to achieve optimal results even on seriously deformed or rutted road. In order to guarantee the desired quality results, an inspector representing the authorized transportation authority should be present at the work site at all times, examining the roadway by means of accepted procedures before and after the treatment. The crew required to operate this small and effective unit includes a single machine operator and a mechanical broom operator. remove surface contaminants, and improve road texture by means of high water pressure. This method, known as captive hydrology process, is suitable for all road surfaces according to a work formula determined by a previously conducted road condition survey. Operating with high-pressure jets of up to 1100 bar, water is injected upon the surface and into the spaces between the aggregates of the asphalt mixture, removing pollutants and excess bitumen, cleaning and retexturing. It is possible to conduct either a superficial treatment at medium pressures, working only on the upper layer, or a total texture renewal through deep, high-pressure penetration. The results are immediately apparent and verifiable through use of calibrated testing devices. The sand patch test is to be conducted every 100 meters and a pendulum test every 400 meters for quality assurance. This machinery, developed and refined according to the stringent requirements of Nittivi Hamifrats Limited, is the largest of its kind in the world and capable of the highest possible output. The work and support crew includes an operator, fuel supplier, technical support, and a water tank. Both technologies presented operate at a very high output on a continuous day and night basis and provide extremely effective results without causing damage to the road surface. Roads do not need to be closed. Traffic continues to flow with almost no interruption, and after the job has been completed, traffic flows much safer.